Everybody, are you all able to hear me?
Yes, sir.
Okay, nice. Yeah.
Yes.
Yes. How are you all?
Good, sir.
Good, Aditya. That's good. Vamshi, are you there? Vamshi, Darshita, are you there? Darshita, Sai?
Yes, sir.
Yes, sir.
Yes. Yeah. So I was wondering, I was thinking we'll start a new chapter today. So, but just before that, let's brush up a little bit of algebra and then we'll start a new chapter. And let's wait for 2 more minutes. Let's wait for other guys. And oh, by the way, did anyone manage to finish the homework question? The question was, you remember we solved two problems on tearing a leaf of a page. I mean, leaf of a book. Yes, first one we had done in class. You remember both of them were previous year RMO questions. The second one we did was a latest RMO question, like 2009, not latest, but somewhat more recent. Right. Aritro, have you got the answer? Aritro or Aditya, anybody, have you got answer to that?
So which one?
See, first one we did was there was a big book and we didn't know the number of pages.
Yes.
And we tore a page and we had to find the torn page number, right? That was the
Yes.
first one. And I think most of you got that right. Answer was 25 pages and 26 pages. I mean, page number 25 and 26.
Yes, sir.
Just one. But we started another problem just after that.
Yes, sir.
Do you remember that?
Yes, sir.
Has anyone got answer to that?
So we did that in class only.
We didn't get the final answer in class that time. See, to repeat the question was this was the homework question. We'll just discuss this till the other people join. Okay, this was the homework, and this was second problem in the worksheet that I had given. Okay, it had a book page numbered from 1 to 100. They were the page numbers, and what was given is some pages were torn. Some pages were torn, and the remaining sum on the remaining pages, sum of numbers on remaining pages. This was 4949. You remember this problem? Yes, guys, it's in your notebook. Do you remember this?
Yes.
Yes, sir.
And then we had to find out how many pages were torn. Now the question was how many pages were torn, right? Has anybody got an answer to this? We started doing it in class, but then we ran out of time. So I said you can think about it at home.
1551 is one combination.
50-51 is one combination, but see, there is an exact answer to this. Okay, there's an exact answer to this. If you tear one page, one possible combination is 50-51. Okay, but there are more possibilities. Aritro, have you managed to get an answer to this? Aritro,
Sir, I haven't.
Okay. Can you try this? This was the second question.
Yes.
Sir,
Yes, Tarun.
is it how many pages were torn at the minimum or maximum?
No, we had to find just how many pages were torn.
But the answer differs, right?
Answer, they can have variable answer, but there can be an exact reason. Means we can reason it clearly. 50 and 51 was one solution we found by trial and error. Okay, but see, but 50 and 51 cannot be a page, you know that. There's a problem with how many pages were torn is the question. 50 and 51 cannot be a page, guys. That's the problem. You understand why? See, first leaf on first leaf, I won't solve the full thing, right? We can solve it on first leaf, first paper will contain page number 1 and page number 2, right? Yes. Second paper will contain page number 3 and page number 4, right?
Yes, sir.
Can there be a page that contains page 51 and 52 on the same paper. 50 and 51 on the same paper. You can't have page 50, page 51 on same paper. It's not possible. The first number will be odd, second number will be even on one leaf, right? Are you guys following this?
Yes.
This was the problem last time. We didn't address this issue. We just went on with it. Okay. So can we now figure this out? If you've not tried it at home, I can tell you some steps. Okay. I can give you a starting point. Okay. You can start by saying let the page number on toned pages be, let's say, let it be an odd, one number will be odd, let it be some 2k plus 1 or 2k minus 1, anything, 2k plus 1 or 2k minus 1 doesn't matter. Another is 2k. Okay, for various k values. Okay, so you can have one set of, if you tear only one page, you'll have only one k value. If you tear two pages, you'll have two k values, like that. Right? Using this hint, would you like to try this for 2-3 minutes? Yes. So let the page number on toned pages be 2k minus 1 and 2k, right? And let's say we are tearing n pages. Let's say, suppose we are tearing n pages. We don't know what's the value of n. Okay. Suppose we tear n pages. Would anyone like to start charting out the steps? Start suggesting steps. Take a minute and you can try. Are you guys following? Do you see the problem here? Like, we cannot have 50 and 51 as an answer. It means, suppose we tear n pages, that means let there be n different k values. N k values. Let the k values be k1, k2, k3, so on up to kn. Okay. So we'll start from here. This is the first step. Then it's the second step. Yes. Now you can try for a minute. I'll tell you one more hint also. Sum of toned page numbers would be 2k. They're the page numbers that are toned plus 2k plus 1 or 2k minus 1, which is 4k minus 1. Okay. And if there are n k values, sum of all toned pages, all toned page numbers would be equal to, it will be 4k1 minus 1. If you're tearing, this is for one particular k. Each k will determine one page. Like each value of k determines one page number. 4k minus 1 plus 4k2 minus 1 plus so on to 4kn minus 1. These are sum of all the toned page numbers. Are you following this? Yes, any problem for anyone? Yes, no. Can you guys please respond? Because we can do this in a different way if you have a problem with this. We are starting by saying the toned page numbers are 2k minus 1 and 2k for some k. And we tear n pages means there are n different k values, n unique k values. And these n k values, we are calling it as k1, k2, k3, so on up to kn. All right. And so this is sum of all toned. And this is guys, I've given you enough hints. Can you try this once now? Please, I'll wait. There's only one answer to this question. I have just solved it some time back. Okay, and I realized the mistake we made last time, which is that this cannot be a page. Okay, please take 2 minutes and then we'll figure it out. Yes. Anybody wants to share their thoughts? Like, what are you thinking? Like, or what's your idea? Anyone? Guys, anybody? Let's just start. Come on, let's start thinking. Are you all tired today? How was your holiday? What have you done in the holiday? Can you all hear me, guys? Aditya, Vamshi, can you hear me?
Yes, sir.
Vamshi, yeah. Are you all sleepy? What happened?
Sir,
Yes, Tarun.
I don't think I understand.
Okay, fine. I'll explain from the start. Let's just do this quickly. See, we don't know which page was torn, right? I'm just counting, keeping yesterday, last time we thought answer is 50 and 51. Okay, but now I just saw it carefully. If you look at, see, 100 pages means there are 50 papers in the book, right? 50 papers are there, right? Individual sheets, there are 50 individual sheets, right?
Yeah.
So
Yes.
first sheet may, first page number will always be odd. Any sheet, first page number will be odd. First page, second page, right?
Yeah.
And
Yes, sir.
second sheet may, the page number starts from 3, 4. Third sheet will start from 5, 6. There
Yeah.
is no
So
sheet
15 and 51 can't be on the same page.
50 and 15 can't be on the same paper. Only 49 and 50 can be there. 51 and 52 can be there. Right? So our
Yes.
answer, last time the answer we thought is wrong. Right? Is that clear so far? This part?
Yes, sir.
And in the next, so we don't know which page was torn. Okay, but we know that any page number, let me write in different color. Any page number is any page number is even plus odd. I mean, any page sum is even plus odd, right? So
Yes, sir.
any paper 1, 2, 3, 4, one is even, another is odd. 2k minus 1, 2k. That's the form we assumed. Do you understand?
Yes, sir.
And yeah, so then let, we don't know which page it is, so let the page number be 2k minus 1 and 2k. Okay, let page be 2k minus 1 and 2k. We don't know k value. K is unknown. Okay, k is unknown. Suppose we put k as 1, we'll get the page as 1, 2. Suppose you put k as 11, you get the page as what will be the page? 21, 22. You understand? Like that.
Yes.
We want to find out. What should be k value. Is the problem clear? Like the problem statement.
Yeah.
Yes.
Yeah. Yeah. So we want to find out which page is torn. Now, if only one page is torn, right? One page cannot be torn to give us the answer. The one page to be torn is 50, 51. If only one page is torn, right?
Yes, sir. But 50 and 50
That
cannot be in the same.
doesn't exist. It doesn't exist. So you cannot. Answer is not one page. The question is how many pages were torn. Answer is not one page.
Okay.
You
I
understand
got
that
it.
much? You got that part? So we want to find out how many are there. So in this, that's first step is clear. The first line that we have written. Yes.
Yeah.
Let the page
Yes.
numbers be 2k minus 1. Next, it's not, answer is not 1, right? So we don't know answer. Let's say we are telling n number of pages. Okay, we don't know n also. We don't know n value also. N can be 5, 7, 10, 15, any number. All right.
Okay.
So for each k value represents one page tone, one tone page. So let the k values be k1, k2, k3, kn. Okay. So in third step, sum of any two tone page numbers will be 2k plus 2k minus 1, which is 4k minus 1. If adding up all the tone page numbers, what should this answer be as per the question in step 4? All tone page numbers. Initially, there were 5050. Some initial sum was
101.
101. Absolutely, absolutely. Sum of all tone page numbers should be 101. Right? So all of
Yes.
this should be equal to 101. Okay, now we're almost done. Vamshi, have you followed this so far? Vamshi?
Yes.
Sai, are you there?
Yes, sir.
All right. So that is sum of all tone page numbers. So in step 5, let's just take this sum. It is 4 times k1 plus k2. Each of them is an integer, right? Plus kn is there. How many ones are here in this sum? How many ones are there?
So
N
n.
times.
N ones. Absolutely, absolutely. I'm glad you're all on board. That's nice. Minus n should be equal to 101. Okay. Let's call it as s. Okay. Some sum. S is equal to some sum. Okay. So 4 times s minus n equal to 101. This is the equation we have. Finally, a Diophantine equation. Do you guys see how Diophantine is coming back? Yes. So we have a Diophantine equation. Okay, where n is the number of tone pages. Okay, n is the number of tone pages. Can n value be, no, see this. I'll rewrite this. 4s equal to 101 plus n. Okay, now just see this. Let's analyze this. Can n be equal to 1?
No.
It's absolutely not possible. Why is it not possible?
Because if n is 1, then 102 is not divisible by 4.
Absolutely, absolutely. Very nice, very nice. Can n be equal to 2?
No.
No, you can't tear 2 pages also, right? Can n be equal to 3?
Yes.
Yes, you can tear 3 pages. So n equal to 3 is a valid answer. Okay, we don't know what are the sum of k values. Okay, so when 4s equal to 104, s is 31. So k1 plus k2 plus k3, any three page numbers equal to 31. Okay, are you following this, guys? This just says sum of 3 natural numbers.
Sir, it's 26. No,
Oh,
30.
sorry, I'm so sorry. Yeah, S26. 4s is right. I'm so sorry. Yeah, it's my mistake. So s is 26. So we have k1 plus k2 plus k3 equal to 26. Sum of 3 naturals can be equal to 26, right? We can find such numbers. Like let's say k1, I'll show you one answer. You can have 1. If you take 1, right? 1, then 1, 2 can't come because it can be 3, 5. You can take all even or all odd. You understand? You get the point. Like all 2 even, 1 odd. Like see, if you choose k1 as 1, right?
Yes.
Page number equal to 2. See, k is page number. Okay, k is
Yes.
page number, and n is the number of pages. If k1 is 1, right? Then k1 plus 1 will be the next page. It won't be k2. You understand? Each one is a page number, guys. K1, K2, K3 is a page number. You can't tear page 1 and page 2, right? Both, right? If you've torn page 1, you've already torn page 2 also. Are you guys following this? K is the page number. Any 3 page number should add to 26. If you take 1, you can guess any number. Take 3 if you want.
Sir, 1, 3, and 7.
1, 3, and 7.
5.
5. But sum should be 26, Tarun. So K2 is 3. Let's say
22.
1, 3, and 22 is fine. Okay, sum K3 as 22. Right? These 3 pages work. If you tear these 3 page numbers, let's check this answer once. Okay, 1 plus 2.
Sir, there 1, then 2 will also be there. 2.
Exactly. So this is the
So
total
don't we
sum.
count that in the sum?
Yes, Tarun.
So don't we count that in the sum?
We are counting that. So 1 plus 2 plus 3 plus 4 plus 22 plus 23. This should be equal to 101, right? 22 plus 23 is not possible. It will be 21 plus 22. Okay, this is not a correct possibility, but you can have some solution for this. Okay, we have to choose numbers wisely, but you can find some numbers. Let's not choose 1, 3, 22. See, this tone sum is what? 3 plus 7, 10 plus 53, right? We want tone sum to be 101. So let's push the page numbers. We have to guess an answer. Let's take, how much shall we boost it?
11.
You can want to try 11.
11, then
Yes.
13. No, not
Okay,
13.
13. Okay, you want to try 13? It's going to be too small for us.
Yes.
Okay, 2, 11, 13 and 2 should be one possibility. In which case you have 11 plus 12 plus 13 plus 14 plus 1 plus 2. So this is too small for us. Okay, so we can analyze, or we have to guess an answer. Anybody has an answer? Darshita, I don't know this. Darshita or anyone?
Sir, maybe like 1, 3 and 45.
1, 3 and 45. That will be best, but some should only be 26 here, Darshita. That's the problem. Yeah, you are restricted by that. So maybe here there is no solution. Okay, we have to analyze cases. So can we have a solution here? Any three numbers should add up to 26. It's consecutive, like any three consecutive numbers. Right? So let's take another possibility. Like we'll come back to 3. Okay, we'll come back to 3. So n equal to 1 and 2 are ruled out. Okay, what should be next value? N equal to 3 can work. We'll examine this. What other n can be there?
7.
7. Next possibility is n equal to 7. So if n is 7, then s will be equal to 108 by 4, which is 27. Okay, s is 27, but sum of 7 numbers, k1 plus k2 plus k3, so on, sum of any 7 numbers should be equal to 27. Is this possible?
Probably.
Probably. If you take even the lowest sum, no, 1 plus 2 plus 3 plus 4, take the lowest possible sum up to 7, right?
Yes.
Take like this, the least you can take, and this itself is 28. Okay, this itself is, you get the point. This itself is 28. So this will have no solution.
So 1 second. So could you scroll up 1 minute?
Yeah, one moment. Is this fine?
Yes, sir.
Yeah. Mm, 4 times. Yes. Yes. Somebody said something. Okay, so n equal to 7, there won't, you cannot have, the page numbers will become too small. Okay, and if you consider what can be next value of n equal to 7 does not work. What can be the next possible n? After 7, next it has to be multiple of 4, so n will be 11. If n is 11, then 4s is 112, s is 28. That's also ruled out. Next possibility is s equal to 28 means sum of 11 numbers must be 28. It's not at all possible. You understand? So we can have solutions only for n equal to 3. Okay, so this is the only possible answer. Okay, we have to find the exact number. Okay, we will do that. But only 3 pages can be torn, like maximum 3. You cannot tear more than 3.
So, but it's asked how many pages were torn. So, like
So
6.
n is the page number of pages torn, right? So 3 pages would be torn. We don't know. Let's find out the exact page numbers in the next step. I'll break this solution down. Okay, until step 4 we were clear, right? Sum of all torn page numbers. Then step 5 we made a Diophantine equation. This was the Diophantine equation. Now we are guessing n values. We are guessing them. Okay, so 4s should be multiple. I mean 4s is a multiple of 4, so RHS should be multiple of 4. N can be 3, 7, 11, 15. For all of these, no, there can't be solution. No solutions can be possible. You understand? So you can have solutions for 3 only. If at all pages were torn, which they are torn, it will be only for 3, n equal to 3. All right, which page numbers they are, we have to figure it out. Okay, please copy this solution down, guys. Take your time. Let's understand this and then move on. If there's any problem, please ask me. So when you write, this question was from 2009 RMO. And when you write Olympiad exams, like that is level 2, you will have time. You will have 40-45 minutes per question. Okay. So I have some previous papers. I'm just looking at them. Anybody managed to find the page numbers? Yes. So in RMO, you get around 40 to 45 minutes per question. Yes. Sujit, are you there?
Yes, sir.
Yeah. Okay. I can copy this and then let's move on. Haritro, did you manage to figure out the exact page number shown, or is there a mistake? What are your thoughts? I'm convinced that it should only be 3 pages shown. You can't tear more than 3 pages.
Yes, sir.
But did you figure out exact page numbers? What the pages were? 3 numbers should add up to 26. Yeah. Any 3 numbers that add up to 26. Okay. Can have it.
Sir, and the torn sum should add up to 104.
Yes, the tone sum should add up to 101. Like in
I don't think that's possible.
is it?
I don't think that's possible.
It's not possible, is it?
I think so.
Okay. So tone sum should be 101. 101. It's 3 pages. Right, let me just guess. Let's guess one number. Let's guess around 20s. Let's take 20 plus 21. I'm just guessing it. 20 plus 21. So we can't do this wrong. 20 plus 21 is wrong. Let's do 19 plus 20. Okay, that's one possible page tone. We have to look in 3 numbers, right? 19 plus 20 can be one possible page. Then this adds up to around 40, right? So let's get something close to 40. Let's do 21 plus 22 can be another possible page. Plus this is given as a sum of 39. This is given as a sum of 43. That's 82, right? So 19 more. 82 plus 19 more should come. We can have page number 9 and 10 being torn. Okay, this is definitely one possible answer.
So, but they don't add up to 26.
1 second. We might have made a mistake. We'll fix our mistake. Okay. We'll fix whatever is the problem with the solution. But I'm just guessing any 3 numbers. 19, 20 is possible. 21, 22 is possible. These are the page numbers torn. So page number 19, page number 21, and page number 9 are 3 possible pages torn. We'll figure the K part. Do you accept this as a solution, guys? Yes, we'll fix the previous part. This is one possible combination. 19, 20 is 39, 21, 43, 19. This works. 82 plus 19. Yes.
13, 15, and 21.
13, 15, and 21 also may work. 13, 14 plus 15, 16 plus 21, 22. Yeah, you can have, this will work. Yeah, you can have many possible combinations. So yes, 3 pages will definitely work. Okay, and higher pages don't work. So we'll fix that 26 part. What that 26 means, we'll fix that. Okay, so definitely it's only 3 pages. Right? If you try to tear 7 pages, we'll figure that. We'll figure the 7 pages part. So what is exactly this K1 plus K2 plus K3? sum of all. So k itself is not our page number actually. K itself is not the page number. 2k is our page number. Okay, 2k is our page number. 2k and 2k minus 1, right? So 2k minus 1 is our page number. Okay, k is not the page number. In step 3, in step number 1, we assume page numbers are 2k minus 1 and 2k, right? So 2k minus 1 is the page number. So if k1 is 1, 3, 22 for these, right? The page numbers are actually 1, 2. Then for 3, the page numbers are 5, 6. And for 22, the page numbers are uh, 9, so 22, right? So 2k minus 1 is 20, so 43, and 2k is 44. I'm sure this will also work. Let's check this. 1 plus 2 plus 5 plus 6 plus 87. 87 plus 3 plus 14. It works. See? So it's 14 plus 87, which is 101. So is it sorted? Like, you understand what the k represents?
Yes, sir.
Yeah. So the page numbers are actually 2k minus 1 and 2k. So this is a valid solution, guys. Like that, you can have various combinations. Yes, is it fine? Please go through this, then we will do a slightly different topic. Vamshi, have you followed this?
Yes, sir.
I want to ask all of you very, very frankly, if you're left by yourself for 1 hour of time, and suppose some hints were given, can you conceive of getting an answer to this? Like, were you able to conceive of getting an answer? Like, not full answer, but will you be able to chalk out the steps? Does anyone feel that way? Like, you just take 1 hour and some hints were given. Let's say step 1, step 2, step 3 are told to you. Yes, anybody feels that way? Can you raise your hand? Or if you don't, then what was the exact problem? Please tell me. Yes, guys, can you all respond? Like, yes, Tarun. Yes, what is it, Tarun?
If first few steps are given, I think I get the answer.
You can guess, you will be able to guess an answer at least, right? Guess some numbers.
Yes, sir.
Yeah. If anybody has a problem, like you don't know how we are getting these steps, you can ask me, okay? You should, first of all, has anybody not understood this solution? Sai, did you follow the solution, Sai?
Yes, sir.
You followed every step. Can you note this down neatly? Have you noted it down?
Yes, sir.
Okay. Would you like to try, everybody, would you like to try one problem on your own? I just want you to feel confident about this. Okay, will you do it? It'll be easier than this. But let's get the art of guessing answers. We'll only guess answers. Okay, consider this problem. This was also in the worksheet. I'm just opening the
So what
worksheet.
was the question?
Which one, Sujit?
So the one we were doing now.
Oh, this was in the last class. You remember we discussed page tearing problems, the first 2 problems from our worksheet.
Yes, sir.
And in the second one, we wrote an answer and we left it. Like we wrote the answer as page number 50 and 51 and we left it there.
Yes, sir.
Yeah, 50 and 51 is not correct, so it can't be correct.
Oh,
Because always first page number will be odd, second page number will be even. First paper will have page 1, page 2, right? Odd and even.
yeah.
So there cannot be a page which starts with page 50 and ends with 51. You can have pages 49 and 50, it's okay. Or you can have 51 and 52. You can't have a single page which has page numbers 50 and 51.
Yes,
Yes. Yeah, that's why our answer was wrong, and we had to figure out another answer, another clean answer.
Oh,
Yes. Guys, can you all try this? I'll give you, you can take 10 minutes, okay? Just figure out, try, you think on your own, take cases, don't get scared. Okay, you're capable of this. You all know enough theory for this. And the question is from our worksheet. Let me just open that question once. Just one moment. Yeah, the exact question is the following. You have to solve for, it's easy, solve for integers x comma y, and the question is x minus y ka whole square plus 2y square is 27. Okay, you think very freely, take a moment. You don't do dangerous identities and all. This was asked in IOQM, like pre-RMO. It was called pre-RMO some years ago. So let me try this. Yes, how are you thinking? Darshita, how are you thinking about this? Like, how do you start this problem?
So like we can take it separately, like x minus y and then 2y square. We can take it separately.
Means, separately means?
Like x minus y square will be lesser than 27 and 2y
Right.
square will also be less than 27.
That's right. Now, Darshita and everybody, you think about, see, you're adding, how do you read this equation? See, it's looking horrible, like two equations, one with squares, everything, right? How do you read it? You're adding two things, addition of two numbers, addition of two squares is coming out to be 27. And second term is greater than a square. It's more than a square. Okay. You can now try to figure out and see that y is coming as a solo object. Y square is coming separately. That's giving you a hint on how to start. Addition of two numbers is 27. That's how you read it, okay? For example, can y be greater than 4? Can y be equal to 4? Is this possible?
no, sir.
Why is it not possible?
So because the first term, like the second term, 2y square, it will exceed 27.
It will already be 32, right? So you have very restrict, think like that. Okay, now I've given you enough hints, okay? You can get this answer for sure. Enough hints. Yes, Anitra, I'm sure you have the answer, right? Or you have a
Yes.
doubt, Anitra. Okay, let's wait. Sujit, let's wait for 1 minute. Sujit, is it a doubt or an answer?
Sir, I got an answer.
Okay, nice. It will be correct. Vamshi, are you getting close? Vamshi and Sai?
Yes, sir. Is the answer a set?
Huh?
Is
Yes.
it a set?
What,
Like,
Aditya?
is it like a set like x y x y x y?
You can get multiple answers.
Okay.
Just wait for 1 moment. I'm getting a call. 1 moment. Yes. Yes. So Srijit or Vamshi, what's the answer that you have? Vamshi?
1 second, says she gets
Yeah.
into.
So why can't we 4? Okay, why? So narrow down y values, guys. So what can y be? Y can be 1, 2, and 3. Anybody wants to proceed from here?
Zeros. Y can zeros.
Oh, 0, 0. Right. 0 also. Yeah. Yes.
Sir, actually, you can also put like plus minus in front of
Negative.
the
Yeah.
1, 2.
Absolutely. It can be negative also. Okay, it doesn't matter. Yeah. Plus minus is possible. Plus minus 2. Actually, 0 is possible, but you can rule it out immediately. Because if y is 0, x square is 27, x can't be a integer. Right? Yes. So, Srijit, can you proceed from here? Can you explain the steps? Yes. Srijit?
Sir, sir, I took y must be smaller than or equal to 3.
Yeah.
And then I checked 27 is close to 5 square.
Right.
So if you take y equals 1,
Suppose we take y equal to 1.
yeah, 2y square is just 2.
X
So
minus 1
x
whole
minus
square.
y the whole square must equal 5.
X minus 1 should be equal to plus minus 5.
Yeah, and then we can get 6 and 1.
Right. Absolutely. It's 6 or minus 4, right?
Yes.
How? Srijit, did you get 6 and 1?
Yeah, x is 6 and y is 1 or minus 4.
Right. Okay. 6 comma 1 or 6 comma minus 4. And like that, you can get the other pairs, right? Yes. So you can try now for y equal to 2. If y is 2, then x minus 2 whole square is 27 minus 8, which is 19. Not possible here. Right? Then y equal to 3. X minus 3 whole square is 2y square is 18. 27 minus 18 is 9. So there is a possible solution here. X minus 3 is plus minus 3. So x can be 0 or x can be 6. Right? That's it. Those are all possible solutions. And you see, the previous problem is very similar to this. Okay.
So we can take negatives also, like y equal to minus 3.
Oh, right. You can get negative answers, right? You'll get few more answers. That's true. Yeah. So you have various points. I think from here you can finish this, right? 0, 3, 0, 6, then 0, 3, 6, 3. You can take negatives also and get various pairs, right? Yes. So this part, I think everybody will be able to finish this, right? Anyone is having a problem? Sai, did you thoroughly follow this, Sai? Sai,
Yes, sir.
have you got this answer?
Yes, sir.
Got it. Okay, nice. Darshita, are you fine?
Yes, sir.
You're clear? Okay.
Yeah.
Okay, so yeah, we'll start discussing a new topic. And before that, we have to be a little comfortable dealing with inequalities. Okay, we'll discuss inequalities for like half an hour, 30, 40 minutes, and then start a new chapter. Okay. So just to summarize, oh, by the way, guys, everybody, on 18th, I think on 14th June, there will be an online test, online accelerator test. All right, it will be online and accelerator test, and it will be based entirely on number theory. The syllabus is only number theory. Okay, number theory plus basics of combination, like permutation and combination. So very basic things. It will be online, and the model will be very similar to IOQM. Okay. IOQM is the first level of Olympiads. Right? So the model will be very similar to that. Okay. So please read a little bit. I can assure you that, I mean, if you pay attention, your skills will really improve. Okay, your mathematical skills, basic math skills will really improve. So take this exam seriously. Okay, try to do it well. Okay, it's on 14th June. Yeah, online. Exact timing will be told to you. Okay, right. So can anyone quickly summarize? Can Vamshi, can you summarize what we learned in this chapter so far before we put an end to this summary of number theory? You can refer to your notes. That's okay. Vamshi, anyone? Vamshi, can you summarize this? Are you aware of what we discussed? Everything? Yes. Can you hear me, Vamshi? Sai, are you aware of everything we discussed in this chapter? Sai,
Sir, kind of, sir.
kind of. Can you summarize it? We'll fill the gaps. If there are any gaps, we'll fill it. You can refer to your notes and you can tell me the
Sir,
summary.
like we did mods.
Wait, let's try to do in order. What was the first thing we learned in this chapter? Like first type of things we did. First kind of things.
Sir, we did like what is it? Squares, like what is it?
Absolutely. We did method of completing squares. We discussed method of completing squares.
Sir, then we did
One-
mods and like
Just one
the
moment.
profit.
Sai, one moment. Method of completing squares. The task is to pack an expression back into a square, right? Pack a given expression into a perfect square.
Sir, can we like review everything like one day?
One day, yeah, into a perfect square. Let's do it right now. That's okay. Like just so that you're all aware. Please make a note of this. In any case you missed any part, you can go through. You can ask me the timeline, and I can tell you which time we did it. You can go through those lectures. Okay, this was packing given expression into a perfect square. Just one example. Like look at this. Let's say you have to pack this back into a square. X square plus, let's say, let's take a even number, a good even number. Let's say x square plus 8x plus 6. Can you complete this square here? All of you, can you try this? You can do it in 30 seconds immediately. Yes. Anybody's got an answer?
So x plus 4 the whole square minus 10.
Absolutely. X plus 4 whole square minus 10. Right? That's correct answer. And the trick is, guys, everybody, the trick is, Aditya, how did you get this so fast?
So I grouped it into perfect square.
Yeah. How did you group it into perfect? Your answer is correct. How do you group it into perfect square?
So like we to complete the square for any quadratic expression, it's like x plus bx plus c.
Right.
Sir,
So like
8x.
b by
Sir,
2.
8x is 2ab, so that means like 4x will be ab. So the second thing will have 4, and then the first one will have x.
Absolutely.
And then after that it will be 16. So I have to subtract 10 to get.
Absolutely. That's absolutely right. Yeah, absolutely right. Yeah. Okay, Aditya. Yeah. So I got your point completely. Yeah. So every time in completing square, whatever is the coefficient of x, that by 2 whole square. Okay, x plus whatever is the coefficient of x. For example, if you had x square plus x square minus 11x plus 1, right? What will be perfect square form of this immediately? Yes, Darshita, what will be the no, Sai, next time. Let's let Darshita get this. Darshita, what's the answer to this? Yes, Vamshi, have you got an answer? Yes, Vamshi, Tarun, have you got this answer? Tarun,
I'm doing it. I'll
what,
do that.
whatever is the coefficient of x, that by 2 whole square, you blindly write like that. Okay, and then adjust the number later. Right. Yes, Sai, you have an answer? Sai or Vamshi, anyone?
So the first part is x. I think it's minus 11 by 2 the whole square, and then we have to adjust the number.
Correct. You have to adjust the constant accordingly, right? And an easy way to adjust the constant also, right? Just blindly write the constant given in the question, plus 1, and subtract the square of the number inside. Like subtract minus 11 by 2 the whole square. Carry forward the same constant first, and then subtract the square of the number inside. Okay, so it's going to be Aditya?
Minus 117 by 4.
Minus some bad number has come. That's okay. Minus 117 by 4. Okay, like that. The first thing we did, completing squares. And then what was the next concept? Guys, fast. You can use your notebook.
So
Yes,
divisible.
yeah, we discussed divisibility, and within divisibility, divisibility. But within divisibility, we did two major ideas within divisibility, which is we learned how to sum an AP and sum a GP. You remember this? AP means what is an arithmetic progression, Darshita? Yes, Darshita, are you there?
Yes, sir.
What is an arithmetic progression?
Um, sir, it's like
Mhm.
adding the first and the last term. I think.
That's the technique, but what is this AP? What is this sequence? Anybody else? What is an arithmetic progression? Anyone? Shujit, what is
Sir,
this?
like
Yes,
a
please,
set where a fixed number is added, like for example, 2, 4, 6, 8.
absolutely. You're adding a fixed number each time to the next previous element to get to generate the full sequence, right?
So what is the full form of GP?
GP is a geometric progression. Okay, and what's a GP? Like, what's the structure of a GP? Fast. Anyone? Tarun, you want to answer this?
Sir, I forgot.
Okay, okay. My point is okay, guys. So what we will do is what
Sir, a common number will be uh,
multiply.
multiplied by another common number which is raised to 1 and then 2 and then 3.
So suppose I'm telling you. So you're right. GP means you multiply a fixed number each time. Fixed number to previous term. Right? That was a GP, right? And it had the structure of a GP was like AR square, and so on. Right? That was a GP. In divisibility, we did both these things. All right. And then we discussed properties of divisibility. Okay, properties of divisibility. Then properties means they were like if A mod BC, that means if A divides BC, that means A divides B, and A divides. Sorry. If A divides, I'm so sorry. In properties, we had things like A mod divides B and A divides C. That means A divides BC, and so many, like there were 7, 8 trivial properties. We had properties. Then we did some problems on divisibility by expanding x power n minus y power n type of things. That was divisibility. And after this, we discussed congruent modulo, right? We discussed congruences. It's a fast way to find reminders. This was regarding finding reminders. Okay. Then finding last digits, finding last 2 digits, last 2 or 3 or n digits. How do you find last 3 digits of a number? What's the principle in it? Yes, anybody? How do you do this? Like suppose find the last 3 digits of 2 power 5 power 32. Last 3 digits of this. How do you do this problem? Yes, anyone knows it? We have done all these things like in detail in class with lots of examples.
Sir, like you can use 2 to the power p minus 1 equals to 1 is congruent to 1 mod p.
That's right here, but the problem is, what are you dividing by? What is p there?
So 6 minus 1, so p will be 6.
No, Sai. That theorem that was Fermat's.
Sir,
Yes,
sir, to
yes.
find the last 3 digits, I think we have to take mod 1000 or
Absolutely. That's absolutely right. We'll check 2 power 5 power 32 is congruent to some number x mod. We have to find that x, right? We don't know what is x. Okay. We don't know what is x. But do you remember a theorem that can help us here? See, the major problem in finding remainder is you want this to be 1 or minus 1, 1, 0 or minus 1. Okay, and what Sai has told is a power p minus 1 is congruent to 1 mod p. That's completely true. Only if p is a prime. What is this theorem called?
Fermat's little theorem.
Absolutely. Absolutely. You can all refer to your notes, no problem. This is a recap of the chapter, that's all. It's Fermat's little theorem. But only if p is a prime, it works. If p is not a prime, you remember we learned another theorem to do this job. A general Fermat's theorem.
So is it Euler's?
Euler's theorem, yeah, Euler's theorem. And what did Euler's theorem say?
So 2 to the any number to the power of the psi of some.
Absolutely. A power phi of n, let's say, is congruent to 1 mod n.
N.
Right? Where as long as GCD of a comma n is 1. Right? And phi of
So
n was
the GCD of 2 and 1000 is not 1.
Yeah, so we have to split it. We'll split it. We'll just figure it. So here it's not very helpful also, right? So we'll split 2 power. We'll figure that. Just one moment. Yeah, this is, I just made it up, but it looks like it's not so easy to do it. Okay, we'll figure that part separately. Okay. And then phi of n was phi function. What was the formula for this? Remember, it was, if you write n as p1 power e1 into p2 power e2, we have done this, into pk power ek. Phi of n was n times 1 minus 1 by p1 into 1 minus 1 by p2 and so on. Yeah, here we are in dangerous territory. 2 power 5 power 32. We'll figure something. Okay. We'll do this problem after the recap. Okay, so but if you're dividing by non-prime number, then we'll use Euler's theorem. It's a general version. See, all these incongruence modulo, right? The basic problem is to find remainders, finding last few digits, checking divisibility, and so on. Right? And these 3 theorems that we learned help us in doing that. Right? If p is a prime, you're sorted. Otherwise, Euler's theorem. And what was another theorem we learned in this context? It was very, very limited application in context. Wilson's theorem, right?
Sir, n minus 1 factorial equals.
Yeah, it's congruent to minus 1 mod n factorial. Right? Mod n factorial. Right? I'm so sorry. Right? This is very limited in application. Right? So this was Wilson's theorem. And what else had we done in this regard? In congruent modulo, there were properties.
So Diophantine equations.
We did Diophantine, but before that, did we miss anything? I'm just wondering. Between congruences, we learned a little bit of just the statement of binomial theorem. Like, we didn't do many examples. Within congruent modulo, we had done binomial theorem. Right? We didn't discuss much problems on this because it's going to come in the next chapter. Like, it's going to be there in more detail in the next chapter. In permutation and combination, we did binomial theorem. Right? Anybody remembers this statement? Yes. Okay, it's a big statement. Yes, you remember it? Rajat, can you tell me? Very nice.
Sir, I think it's NC0.
X plus y power n can be expanded as NC0.
X power n. X power n minus 1.
Right. It will be x power n. You're right. X power n and into y power 0.
Y power 0 and
then keep increasing. Yeah.
X power n minus 1, y power 1.
Absolutely. And keep adding it up. X power n minus 2, y power 2 plus so on. Right. Last में we'll have NCN. X power n minus n is 0, y power n. Okay. And this NCR, the formula was, anybody remembers this formula?
Sir, n factorial by r factorial times n minus r factorial.
Absolutely, absolutely. That's right. And you can calculate this. N factorial means product of all numbers before that. Right? And then you can calculate using binomial theorem, x plus y power n, x plus y cube, x minus y cube, power 5, 6, any powers you want. Okay. Discuss binomial theorem, but not many problems on that. Okay. And then we discussed some problems on factorials, right? some problems on finding number of zeros in a factorial. Okay, we did some problems on factorials, and then we discussed Diophantine equations. Like in this,
Sir, can you please scroll up?
just 1 second. I'll scroll up. The problems on factorials are mostly finding number of zeros, number of end zeros. See, I'll ask you a question after this. I found an interesting question in the worksheet. Number of end zeros in a factorial. And we did another type of question, which is given number of zeros, finding the number. Given number of zeros at the end, right? Finding the original number. Right? We did that, and then we did Diophantine equations. Some type of Diophantine equations. The basic idea in Diophantine equation was, what we discussed was to factorize, if at all possible, and start by trial and error. If trial and error is not the answer, and start by clever trial and error. Let's use the word clever trial and error. Yes, that is a basic, that is a summary of, I believe, what we had discussed. Have you missed anything? Can you remind me? Sai, is this what you wanted, or do you want me to scroll more up?
No, sir, it's fine, sir.
It's fine. You have written binomial theorem. Okay, so please read these, guys. Okay, in IOQM exam, we'll try to finish all the chapters before that, but my suggestion would be, in IOQM, your good bets can be a number theory. You can bank on this number theory plus permutation and combination plus basic algebra. Geometry is a major chunk, but the plan is, once we do number theory, we'll do a little bit of PNC plus basic algebra, and if we have more time, we're going to next do geometry section. Okay, or if you're getting bored after permutation and combination, let's start doing geometry. All right, but this can be, as of now, the topics you will give importance to. You get it? So try to ace number theory, like try to ace your 14th cut test. You'll feel so confident. All right. Yes. Have you missed anything in this summary? Anybody? Yes, I think this mostly covers what we discussed. Okay. So shall we do things faster or slower? What's your thoughts? How are you finding class? Can you tell me now? One chapter is done. Okay. Yes. Is anybody finding the pace too fast or too slow? Who is finding this too slow? Can you raise your hand? Whoever is finding this, we can do things faster. You feel we can discuss topics faster. Yes. Who feels that we should do things slower? Anyone? Can you raise your hand? Are you all able to hear me, guys? Is this pace nice?
Yes, sir.
Not,
It's fine, sir.
it's fine. Is anybody not fine with this pace? Anyone? Darshita, are you fine with this pace?
Yes, sir.
Yes. Please tell me if things are going too fast. Okay. So we can keep and I want you to read well. First test, ace it. Okay, you'll feel really confident. Okay. So next, yeah, you can keep a heading. This is basic algebra, little bit of basic algebra. Only in few minutes. We'll finish this in few minutes. We need how to analyze inequalities actually. So we have learned. So you can keep the subheading as basic algebra. Okay, only just very, very little, and that is inequalities. Okay, these will keep coming in the future chapters, and I think it's worth knowing this before we do next chapter. Okay, so we're coming back to the realm of real numbers. We're coming back to real numbers for now, only for now. Okay, and those who are in 9th class, how many of you have seen these things before, like solving inequalities? How many of you have seen it outside this class? Can you raise your hand? whoever is in 9th or 10th also, like Aditya and Vamshi, have you seen solving inequalities? Aditya,
Not yet, but like I have solved inequalities.
you have solved it. Okay, okay, nice. That's good. And Vamshi, what about you?
So I haven't done inequalities yet.
You haven't seen. That's okay. I just want to know it. And 9th class, what about you, all of you guys? Are you aware of how to deal with them? Yes. Who is not aware? Can you raise your hand? Whoever is not aware of inequalities. Very, very basic, ultra basic inequalities. Everybody who is not aware, can you raise your hand? Sai, Darshita.
Sir, like maybe if I see it, I might get an idea. I don't know what they are.
That's okay. That's okay. Sujit, you're aware of inequalities? Little bit.
Yes, sir.
Okay, that's good. So let's do this quickly. If anybody is not on board, you can all put your hands down, guys. Okay, look at this. In this greater than sign, equal to sign, and less than sign, these are comparators. Okay, these are called comparators. Basically, they compare things. They compare one side with another side. Is one side greater than another, less than another, equal to another? Okay, so all the rules of equations apply here. Okay, almost means, so let me write it. Almost all the rules of equations apply here. Okay, example. See, what is the answer to this? Can you answer very, very fast? Vamshi, what is the answer? Very, 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 very fast.
So x is 5/2.
That's right. Okay, now, but it's one number. Only one number solves this. Now, suppose you have 2x greater than 5, right? What will be your answer? Yes. You can just transpose 2 to right side or multiply both sides with 1/2. You'll write x greater than 5/2. Okay, that's your answer. So the answer is any number greater than 5/2 works. Any number greater than 5/2 works. If you put x as 10, 2 into 10 is greater than 5, right? It works. Put x as 7, it works. Put x as root 36 or root 33, it works. Any x greater than 5/2 works, right? So there are infinite answers to this, or infinite solutions. Yes. You all follow this? Is anybody didn't follow this? Yes. So you can treat them just like an equation. Okay, treat inequalities just like an equation. Okay, but just there is one danger. Okay, the danger is the following. See, if you have can you note this down? Just it's a very easy example, but let it be in your notes. Okay, this is the key point, that when you see inequality, don't get scared. Everything, all the things about the equation, like multiplying by 2 on both sides, dividing by 5 on both sides, all of them work. You can do all kinds of things. Transposing things around, adding 5, minus 2, all of them are allowed. Is this fine? I'll tell you what won't work. There are some illegal things which can damage us. I'll tell you what they are.
So can you square both sides?
You can square both sides. You're safe. There are some dangerous operations. The main danger is multiplication. Okay, I'll tell you what. That's why the keyword is almost. You can square Sujit, but there's one caution. Okay, can I scroll? Have you copied this? Yes. If anybody wants me to go back, please tell me. Okay, like look at what will not work. Okay, I'll give you an example of what won't work in red color. Okay, we know that 2 equal to 3, right? Sorry. What am I writing? 2 is not equal to 3. Suppose 2 equal to x. We can write minus 2 equal to minus x, right? This is correct, right? Yes, we can multiply with minus 1 on both sides. And 9th class people, you remember this is from Euclid's axioms. Not postulate. You remember we did 10 axioms, right? Few axioms. This is from Euclid's axioms. Yes. But the danger is, suppose, look at this inequality. Do you agree this is correct? 3 greater than 2? It's correct? Yes. What will happen if you multiply with -1 on both sides?
No.
You get -3 greater than -2, right? If you multiply with -1 on both sides, you're going to get this. Is this correct? It's obviously
No.
wrong. So whenever you multiply with negative number, you have to flip the inequality. This sign flips. Okay, you have to be very cautious of this. Okay. The main problem is multiplying by a negative number or transposing a negative number causes the inequality to flip. Greater thans become less thans and less thans become greater thans. Do you all follow this, guys? Is anybody not following? Please, like, let this be utterly clear to you all. In 10th class, I think there is a separate chapter. We're going to discuss it as a separate chapter in school. And in 9th, we have linear equations. This is just one step ahead. Yes, like look at this. Suppose you have another case. Suppose you have x greater than 2, right? So you'll have, that means if you multiply with -1, you'll get -x as less than -2. Do you all follow this, guys? Yes, can you all respond? Is there a problem or you understand this? Yes, you understood. Are you all in ultra holiday mode? You seem to all be in full holiday mode. Yes. Darshita, are we still in holiday mode, Darshita?
No, sir.
Holiday is done. Okay. Can you try one example? One example is just solve for x or solve for y. And the example is 7 by 3 minus 5y is less than let's say 8. Can you solve for y? Take a minute. Please try not to make a mistake, okay? Has anybody got an answer?
So -17 by 15.
-7. No, y less than or greater than? Like what? What's the
Y
exact?
is greater than -17 by 15.
Okay, so you have. Can you want to explain your steps?
Okay.
Means.
So first, what I did is I took 7 by 3 on the other side. So
Okay.
that makes -5y is
Yeah.
smaller than 8 minus 7 by 3.
Right. And then LCM.
And yes.
Yes. So it is 8 into 3, 24 minus 7 is 17 by 3. Right?
I took -5 to the other
Right.
side.
Right.
And then I flip the sign.
Yeah, it will be y will be greater than a -17 by 15. Right? And that's the answer. You can check. Every time in here, you have so much freedom to check. Y is greater than -15. Can you tell me any one y greater than -15 by 17? Tell any one number. Any one. Any.
14 by 7.
14. No, you can 14 by 7. That's fine.
Minus-
Can you tell a simpler number? Yes, Sujit?
Sir, 1.
1. Fine. Y equal to 1. Does it work? Does it solve the problem? Substitute here and check if it solves or not. So you get 7 by 3 minus 5, right? Is this less than 8 or greater than 8? Does it work? Is it less than 8?
Yes, sir.
Yeah, so this will be a valid answer. So y equal to 1. Any number greater than -17 by 15 works. Okay. This really easy. It's just like linear equation, but you have to be careful when you take negative numbers around. Okay. Anybody has a problem with this? Anybody didn't get this answer? Or you want to discuss anything, or anything's not clear? Yes. Can you try one more example? Have you all noted this down? Is anybody still noting this?
No, sir.
No? Anyone? Darshita, are you fully on board, Darshita?
Yes, sir.
Yes. Okay, nice. Okay. Can you answer this question? This next one, which is this is example 2. Example 2. The question is let's solve. When is this possible? X squared minus, let's say, 5x plus 6 greater than 0. Can you solve this problem? Like, what should be x such that x squared minus, it's not equal to 0, it should be greater than 0. Can you try for 2 minutes? What's the factorization of left side?
X minus 2, X minus 3.
X minus 2 into x minus
2 and
3,
3.
right? Greater than 0, right? Yes, Rajit, this is what you wanted to say?
So any number greater than 2 and 3.
2 and can you tell one number which will work? Any number which will work.
4.
X equal to 4, it works because
I think greater than 3.
right. So can you tell me any other number? 4 is valid. Which can you tell me a number which will not work here?
2.
2 will not work. That's true. 2 and 3 won't work because 0 can't be greater than 0. But can you tell me any other number which won't work?
1.
1. Will 1 not work? 1 minus 2 into 1 minus 3, which is minus 1 into minus 2. Is this greater than 0 or not? It's 2. It's
Yeah, it will work.
1 works. One number which won't work. Anyone?
0.
0. But 0 works, Aditya. Minus 2 into minus 3 is 6, right? It works.
It does not work. Okay.
Some number which does not work. Okay, how do you figure out when will it not work? How do you think about when it won't work?
Sir, it can only not work if it's 2 and 3. Otherwise, it will work.
No,
think.
no, there is a small catch here, Sujit. 2 and 3 are correct. It won't work for 2 and 3, but there's a catch here.
So minus 2 and minus 3.
They will also work. Let's see. If you want to take x as minus 2, you have minus 2 into minus 2 minus 3, which is minus 4 into minus 5, which is 20. You're safe. It works. Okay. Anybody has found a pattern to when this will fail? When will this fail you? Okay. Vamshi, have you figured something? Any number which won't work for this? Vamshi or Sai or Darshita, anyone? Yes. Vamshi, have you figured something?
Not yet, sir.
Okay, I'll share the idea. Let's do this quickly.
One
And
minute.
yes, okay.
1 minute.
But yeah, you can do it. You can definitely do it. I'll wait for you. Yeah. And see a pattern, okay? Only a hint is, think of this as a single number A. Think of this as a single number B. You have A into B greater than 0. So what should be the sign of A and B? Signs of A and B, numerical signs.
So plus and minus.
You
One
want
should be-
product. Yes, Rajat?
One should be positive and one should be negative.
For it to fail, one should be positive, one should be negative, right?
Yeah.
Yeah, so x minus 2, let's take any one. X minus 2 is positive and x minus 3 is negative, let's say. Can you tell any number which is in this range, which is in this block? Any number, take a guess.
2.5.
2.5 is correct. 2.5 will definitely fail. Okay, because 2.5 minus 2 into 2.5 minus 3 is a negative number. Is 0.5 into minus 0.5, it's a negative number. It will definitely
So
vanish.
any real numbers between 2 and 3 will fail.
Absolutely. That's clear. Did everybody follow this? Did anybody not take a minute and think about this? You're right. That's your answer, and it's correct answer, including 2 and 3, right? Here, you can include 2 and 3. Yes. Yes, it's clean. Sai, did you follow this, Sai? Sai and Darshita.
Yes, sir.
Yes, please take your time. You can take 10 minutes, take how much of the time, but let this be really clear, guys. Okay. To be honest, all of this, what we did just now, we discussed it in 11th class bridge course because it's present in almost every chapter in math. Every chapter has inequalities. Almost every chapter. Okay. And even in permutation and combination, we'll come across inequalities. They won't be algebraic inequalities. We should know how to deal with them. Okay. And that's the reason we are doing only this particular section. It's extremely important. Okay, it's very easy. Okay. So take a moment, and Tarun and Darshita, like who is not responding, only if you're clear, we'll go on. Okay. Would you like to try another example? Try one on your own. And the problem is, I'm writing it in different color. So answer to this question is for when is this positive? So when is this positive, guys? What's the answer? Final answer. When will this be positive?
Uh, uh,
For x lying between 2 and 3, it's negative, right? It's negative, right? So when is this positive?
Sir, I think smaller than 2 and greater than 3.
Absolutely right. You're 100% correct. When x is greater than 3 or x can be less than 2, this will work. Between 2 and 3, it's negative. Everywhere else, it will be positive. Right. Tarun, have you followed this?
Sir, is it like this for all quadratic equations?
It will be same. It will be same story. Okay. Tarun, are you there? Tarun,
Yes, sir. I
have you
found it.
followed this? You followed it completely?
Yes, sir.
Yes. Vamshi, have you followed this completely?
Yes, sir.
Vamshi, what? No problem, right? No problem. Darshita, what about you? Darshita,
So clear.
thoroughly, absolutely clear. Can you try one more example of this type? The example 3, everybody must get this answer. After this, I'll tell you a method, a general method to do this. The question is, you want to solve for x. Take a moment. You can use quadratic formula. X square, let's say minus x minus 2 is less than 0. Very simple. Only when it is less than, or let's say less than or equal to 0 also. So we'll write this symbol for less than or equal to. It can be less than or equal to 0 also. Anybody has got an answer? What are the roots of the left side? What are the roots of this? Has anybody got this? What are the, just tell the roots of left side, nothing else.
Roots.
Like roots or whatever is the factorization.
One minute, sir.
Take your time, no problem.
So x minus 2 and x plus 1.
Fine. X plus 1 into x minus 2 is less than equal to 0. Can you guess one root now? It should be negative. Guess negative or positive, any one. Guess any number.
Negative or positive?
Take any x. Check with, guess with any x.
20.
Okay, is 20 gonna work for you? So x equal to 20. Is it gonna work for you? 21 into 19. Is it negative?
No.
It fails. 20 fails. Can you guess something reasonable that can work?
Minus 2.
Minus 2 works. Does it work? Minus 2 plus 1 into minus 2 minus 2. Minus 2 also fails. It's minus 1 into minus 4. This also fails, Aditya. This fails. By the way, before we discuss it further, who has a problem getting this? Can you raise your hand once? Who has a problem getting the factorization? I'll tell you a much faster way to get it. After this example, I'll tell you a technique to do this. Okay, but is there anybody who has a problem getting this factorization? I can help you how to deal with that. Yes, you all got this factorization. Sujit, Sai, did you get this factorization?
Yes, sir.
Yes, sir.
Okay. Then what do you check? Take any number that works. Can you see an obvious number that works? Obvious number.
Minus 1.
Minus 1. Minus 1 will just work. Minus 1 plus 1 will be
Minus
0.
1
2 will also work. It just
to minus
works.
0.5.
Minus 0.5 works. Minus 0.5 works.
1.
Yeah, 0.5 into, yeah, 1 works. So can you guess the range where it works?
The minus 1 and 2. Between
Absolutely.
minus.
Any x lying between minus 1 and 2 work. Right? And how are you telling this answer, Sujit? It's correct answer, but how are you telling this?
Because these are the two roots of the equation.
That's correct. So anything between these will work. Why will 0.5 work? Like, why do these things work? It's because, anyone, Aditya, you want to explain why these roots work? Any number between minus 1 and 2 work, any number. Why does it work? Because this product will be negative, right? Like it is one number, it's another number. Product of two numbers is negative. That means A and B have opposite sign. Right? Have opposite sign. The way to visualize this, so now everybody, this is the formal way to do this. What we have been doing through guesswork, right? We tried guessing it, right? So many years back, mathematicians have done it nicely. Like they've made this guesswork systematic. Okay, and the method is the following. This is extremely important, guys. I think that in all of algebra, this is the most important result. Okay, and this method is called wavy curve method. Okay, please note this down. We will solve both these problems through wave. I'll explain in detail how to do this. It's really simple. Wavy curve method, or in some books you will find it as method of intervals. Okay, it's called method of intervals or wavy curve method. Okay, and the idea is in first step you identify this. This is as of what we know in math, in our high school math. It's mostly the only way to solve inequalities. Okay, it's mostly the only way. There are some exceptions, some special inequalities. Okay, only way to solve inequalities of degree greater than 2, of degree greater than or equal to 2. This method works even for degree 1. Okay, so it works for, it's mostly the only way we know. to deal with inequalities. Okay, and so the first step is to identify the roots of the polynomial, roots or zeros or solutions, zeros of the polynomial. Okay, example, in the problem we had dealt with x square minus x minus 2, right? If you didn't know the factorization, that's okay. All right, you can use quadratic formula. Yes, Vamshi, can you quickly tell how do you do this using quadratic formula? Like very quickly. Yes, Vamshi. Darshita, yes, Vamshi, you want to answer? Vamshi or
One
Darshita?
second.
Yeah. Darshita, do you want to quickly tell how to do this using quadratic formula? Darshita,
Sorry, no, I forgot.
I forgot. Yeah. Please, this quadratic thing. Please don't forget. Like, they're really important. Okay, please don't forget them. All right. Tarun, do you want to quickly tell the quadratic formula?
B plus or minus root of B square minus AC by 2A.
You're right. Yeah, you're almost close. Very, very close. You're right, actually. When you have the equation ax square, there's a fast way to do the problem. Instead of trying to find splitting the middle term, if you have this as an equation, roots are simply minus b plus or minus root b square minus 4ac by 2a. Okay. We prove this using completing squares. This comes by completing squares. Right? It's a fast way to do the problem. Okay. Please remember this formula. Like it's worth, it'll come everywhere. It'll come in every chapter. Everywhere this will come. Okay. Please remember this. It's to solve it. Has anybody seen? Do you know that it's very, very hard to solve cubic equations?
Yes, sir.
Yeah, anybody knows cubic formula? Do you know that there's a cubic formula?
So I know for
I know it's very
polynomials,
long.
One moment. Aditya, what are you saying?
so I know for polynomials like sum and all.
Like sum of roots and all.
Yes.
Yeah, that's nice. I'm asking about solving the problem, means finding roots. Suppose I give you an equation, x power 3 plus x square minus 11x plus 17 equal to 0. You want to solve this problem, like find x from here. It's very, very hard to do this job.
So it's like the formula is
I know
very
it's a
long.
very lengthy formula.
This is a very lengthy formula. Anybody knows the name of that formula? Arithro, do you know how
Sir,
cubic is solved? Yes?
sir,
Do you know how to solve a cubic?
sir, no, sir.
Okay. There's a formula called Cardano's formula. It's very big, okay? It's very, very big.
Oh,
And
sir, I actually have seen this formula, but like I don't know. I haven't been able to memorize it yet.
no, it's not worth it.
Has-
It's like
It has too many terms.
too many terms. It's not worth doing it. My point is,
I've heard about this, sir.
it's good. Yeah, and it's a long formula. Okay, it's a long formula, and even in if you finish 12th class, in 11th and 12th, you don't have anything beyond quadratic equations. This is the most complex things can get. Okay, I mean you don't have solving equations more complex than that. Even if you do BSc in math, mostly you'll never solve a cubic equation. Okay, it's just too lengthy. Okay, so only quadratics are there, linear and quadratic. That's all you'll encounter. Okay, so please remember quadratic form. Anybody knows how to solve fourth degree equation? Anybody knows it?
So that's an even longer formula.
There is a way to do it. Yeah, there is a way to do it. And beyond degree 4, you cannot solve the equations. Like there's a hard principle that equations beyond degree 4 cannot be, there's no formula, there's no fixed formula to solve equations beyond degree equal to 4. Cannot be solved. You cannot solve them using a formula. You can do some gimmicks like guessing and all. There's a strong reason why you can't solve it. So yeah, the point of all of this is that please don't forget quadratic formula. Those who are in 10th class, it's also there in your syllabus, right? Don't forget it. Okay. Anyway, let's come back. So first step is identifying the roots. Here the roots are x is -1 and x equal to 2. Okay, those are the roots. Second step is very, very easy. Second step is you plot the roots on the number line. Plot only the roots on the number line. Okay. So here draw a number line and plot the roots. The roots are -1 and 2, right? Mark only these numbers. Don't mark anything else. Now we will assign a sign convention. I'll explain this sign convention. We'll start from plus on the rightmost side. I'll explain what this is. Okay, this is the same technique you have used to solve previous two examples. Just formalizing it. I'll explain what this means. We'll write plus in the very starting, and then we'll alternate plus and minus. Because it came plus, nearest its neighbor should be minus. Because minus came here, this neighbor should be plus again. Suppose it's a cubic, right? Then there will be 4 regions, plus, minus, plus. It's a sign convention. What this plus means is, this is all numbers x greater than 2, right? All of x greater than 2. All these work. Okay, they all work. That's what the plus sign means. Okay, plus sign means greater than works. Minus sign means less than works. Works means, let me write it clearly, less than inequalities are solved here. Plus is for greater than inequalities. So for example, can you note this down? With an example, this will be made so clear, guys. Don't worry. I've used words greater than, less than. I'll just show you. Can you copy both these points, please? I'll show you with an example, like clearly. Don't worry. Has anybody heard of depressed cubic equations, by the way? What are depressed cubics? Anybody
Uh,
Yes, Aditya.
I think so, like cubic equations which can't be solved with cubic formula.
No. Cubic formula. See, quadratic formula can be solved. These two formulae, they work everywhere. Okay, no exception. Quadratic formula, 100% you can solve any quadratic equation with it. With factorization, without factorization, anything. So depressed cubic means x squared term will be upset. Okay. We'll talk about it separately in polynomials chapter. Have you all noted these points? Everyone? Vamshi, today I feel that all of you are so sleepy. You're all so sleepy. Can I scroll? Yes.
Yes, sir.
Yes. Try, look at one example. I'll show you how it's done using this. Using this wavy curve method. Okay, look at this example. Let's say you have to solve for x. Solve, let's say, x square. Some roots are horrible here. Okay, factorization cannot take place. Let's say x square minus x minus 3 greater than 0. Okay, solve for x. Okay, can you do the first step? I'll do it from here onwards. Can you find roots first? Use quadratic formula and find the roots. You can refer to the formula above, the one that I had written above. Yes, please find the roots of this. Anybody got the roots? Just plug them blindly into quadratic formula. Get the numbers, that's it. Yes, roots, psi.
So x minus 2 and x plus 1.
No, Aditya, you cannot factorize this. Please don't do factorization. It works in many, it's a beautiful method, but it works only in very specific cases. Use quadratic formula, no?
Sir, is it 1 plus or minus root 13 by 2?
That's correct. Yeah, there's some bad number, not very nice numbers. It's 1 plus root 13 by 2 and 1 minus root 13 by 2. Those are the roots. These come directly from quadratic formula. Like here, you write x equal to minus of minus 1 plus minus root b square is minus 1 ka whole square plus, so it's minus 4ac. So it is minus 4 into 1 into minus 3 by 2. 2a, 2 into 1 is 2. So these will be the roots. Okay, that's the first step. Second step, just mark the roots on the number line. Take number line, and the lower number is 1 minus root 13 by 2. Larger number is 1 plus root 13 by 2. Okay, take them on the number line. So this is plus minus plus. What this means is, can you guess one root to this? Like looking at this, can you guess one root? Just look at, take any number, any x of your choice. Yes. Vamshi, can you guess a root to that? To the yellow equation? Don't be modest. You can take any x, any x. Can you guess one x? Yes, Vamshi. Take any, do trial and error. Take any x. Yes, Darshita, can you guess any x? Any x?
1.
One doesn't work, right? Take a number. See, if you put 1, you get 1 minus 1 minus 3. Is it greater than 0? Can you guess one x? Any other x? Anybody else? Can you just guess one root?
3.
3 is fine. Why don't you take 100 and 10,000? Like, will x equal to 10,000 work? Does this work? If you take
Yes.
x as 10,000, does it solve the problem? 10,000. Why are you thinking for so long, guys? It's so simple, right? It's just like in the previous case. What happens is, here the roots are 1 plus minus root 3, right? So the factorization of this will be actually x minus of 1 minus root 13 by 2 into x minus of 1 plus root 13 by 2. Okay, greater than 0. It's the same. Last time you had some nicer numbers. You had nice integers. Here you have some irrational numbers. So any x greater than 1 plus root 13 by 2 will work. Any x in between them will fail. Any x less than this will also work. So you'll simply write the roots of this are, the answer will be x less than 1 minus root 13 by 2 or x greater than 1 plus root 13 by 2. It's like in the previous problem only, but previous problem you had nice integers as answers. Okay, and in this problem you have some irrational numbers, but the basic idea is same. Yes, do you follow this? Please take a minute, and if you're all set, then let's move on. First step is find the roots. Second step is mark them on the number line and mark the roots. Start from the rightmost side. Plus means greater than works. Inequality is greater than, so it works. Minus means it's the solution region for less than symbol, right? So for example, if the problem had x square minus x minus 3 less than 0, what will be answer to this blue inequality? Yes, anybody? In the original question you had greater than 0. Suppose you have less than 0, what will be the answer?
Sir, 1.
Sir,
Varun?
any number between 1 minus root 13 by 2 and 1
Right.
plus root 13.
Absolutely. So if it is less than 0, any number, this will work. This will be the solution region. That's it. You just have to understand this. And it's the same reason, because the, yes, Rajan? Yes, you're saying
Can
something.
1 plus root 12 by 2 work?
Yeah, 1 plus root 12 by 2 works. I mean, for less than it works. We have to check. Wait. Let's check. What is root 13 value approximately? What is this number? Yes,
So 3.6.
guys. 3.6, fine. 3.6 is okay. 3.65 something. Okay. So 1 minus root 13 is 1 minus 3.6 by 2, which is like minus 1.3. It's around, this number is like minus 1.3. And this number is 1 plus 3.6 by 8. So it's 2.3. Any number between these two works, right? So Srijit, you want to check 1 minus root 12 by 2, is it? You want to
Yes.
check that?
So
Yeah.
plus.
1 plus. Okay. So root 12 is 2 root 3. So it is 1 plus 2 root 3 is like, root 3 is 1.72973. 2 root 3 is like around 3.46 by 2. 4.46 by, it just works. Okay, it just works. It will lie somewhere just to the left of this. It just works. You get it?
Yes.
Yes. Okay, let's do one last example for today and then we will take a break. But you have to do this. Please don't wait for me, okay? I want you to do this. Okay, everybody must get this answer. Okay, this is the last example for today. Okay, solve for y and the problem is 2y square plus 5y plus 2, okay, is less than 0. Can I do this? Everybody, I want you all to do this. The last of this type. So in next chapter, we arrive at conditions like NC2 greater than NC3 and things like that. Sorry, NC2 less than N1C2 less. So we'll have to deal with quadratic inequalities in the next chapter. You can just follow the steps, find the roots, and draw the number line and so on. Has anybody got the final answer in this? Sujat, you were very nice, Sujat. It's good. Let's wait for other people. It's very nice, Sujat.
So I got it.
You got it. Very nice. That's really good. It's good. Sai, what about you, Sai? Sai, Darshita.
Yes, sir.
Sai, have you got answer?
Almost.
Almost. Fine. I'll wait. Darshita, what about you?
So done, sir.
Done, Darshita. Very nice, Darshita. What is the answer, Darshita, that you got?
So -2 and -1 by 2.
So what should be the range of y? Like, what should be the correct answer? Those are the roots. That's correct.
Like y is greater than -2 and it's less than -1 by 2.
Absolutely right. Very, very nice. That's very, very nice. Right. So if you did factorization or if you use quadratic formula, you will get y is -5 plus or minus root 25 minus 4 into 4, which is 16 by 2 into 2, which is 4. Right. So the roots will be -5 plus 3 by 4 and -5 minus 3 by 4. So the roots are -12 and -2. Right. So mark them on the number line. So -2 is the smaller number, -half is the larger number. Mark them, and the sign convention is same: plus, minus, plus. Minus is the part where negative numbers work. So y is any number between -2 and -1/2. And that's it. That's the answer. Right? Is it the same answer that you got, Srijit and Aditya? You got anything different?
No, sir.
Okay, very, very nice. Very nice. Okay, this is all. Now we are all set to do the next chapter. Actually, permutation and combinations, it's my favorite chapter. It has no formulas and it's just too much fun. Okay, so it'll be really nice. I hope none of you miss class. In the remaining 5-10 minutes, you can go through your notes, guys. Like go through all of number theory. I missed something in number theory review. Can anybody tell me what we missed? In the list of topics to discuss, we missed a major topic. You can go through your notes in the next few minutes.
So you must, I think, some Chinese remainder theorem.
We are yet to discuss Chinese remainder theorem. Chinese remainder is true, but we didn't discuss it in class. But in the summary, we discussed something in class and we missed it in writing the summary in the beginning. This. We didn't discuss Chinese remainder, we'll talk about it. Chinese remainder is about if you have a system of congruences, okay? It means you have to solve for a set of congruences together. We'll talk about it in doing problems, don't worry. But we missed something on LCM and HCF. Okay, we did LCM and HCF properly, like LCM, HCF. And in HCF, important thing was we did Euclid's algorithm to find HCF. Okay, this is very important. Okay. So among Diophantine and all, we discussed LCM, HCF. Okay, in the next few minutes, please go through your notes, and if there's a problem, ask me, right? Yes, so Chinese remainder, we'll talk about it very soon. You can see from the start everything in number theory and today's class. Today's classes major part was solving inequalities up to quadratic inequalities, finding solutions to that. If you have any problem from worksheet or anything we can discuss it. Okay, if you've seen the worksheet is really good. If you can solve 50% of them, then you're doing fine. You're doing really well.
Sir, I had a doubt in the worksheet.
Yes, Tarun. What?
I'll tell the problem. It's the
Sure,
fifth
sure.
one.
1 second, Tarun. Can you tell the question? Like, what's the question?
Yes, sir. 101 into
Right. 101 into
100 into 10001.
1 and 2, and this has
Yeah.
and this had
Last
2 power.
last number ends with 2 power 7 minus 1 zeros.
Right. And the question is, how many zeros are there in between, right?
Yes, sir.
How many zeros in the full number? How many zeros are there in this product?
Sir, it asks us to find the product and the zeros.
It asked us to find the product also. You have to find the product also. Find 2 parts are there. Find the product and find the number of zeros also. Like find the product also, right?
Yes.
How do you start? Yeah, has anybody a starting point? Give us just a starting point.
Sir, for how many zeros? There are at the end of the thing. There's no zeros.
At the end of the thing, yeah, at the end, what will be the last digit of this number? If you do all this multiplication, last digit will be 1, right? So at the end, there are no zeros. The number ends with 1. How do you figure this? Like,
Because there's no 2 and 5.
Tarun?
Like 101, all of them are odd numbers, so they don't have multiples of 2s, and they're just 5 n plus 1, so they don't have multiples of 5.
Sure. But how do you find this answer? So if you've tried it, one moment. The idea is, you want me to tell the idea, or see, the idea is, write this as, look at each number. Each number is 10 power k plus 1 form. Each term is 10 power k plus 1. Do you see that? Like
Yes,
this
sir.
term is 10 square plus 1 into 10 power 3 plus 1 into 10 power 4 plus 1, right?
Into
Into
10
so
power 9.
on. Into 10 power, what will this number be?
2 power 7 minus 1.
It's going to be, actually, see, 2 power 7 minus 1. I mean, in the sense, see, this has k, first term has k equal to 2, right? Second term has k equal to 3. Third term has k equal to 4. There are 2 power 7 minus 1 zeros. Then here k will be 10 power 2 power 7 plus 1. Do you see that? Like, first term is 1 0, right? 1 0 means k equal to 2. If you have 1 0, k value will be 1 plus 1. If you have 2 zeros, k value will be 2 plus 1, right? So if you have 2 power 7 minus 1 zeros, k value will be 2 power 7 minus 1 plus 1, which is 2 power 7. That's the last term. Okay. So the number given in the question can be reduced to this. You can write it like this. Yes. So far it's fine.
Yeah.
Did anybody who's seen this, and Arithro, have you solved this problem? Arithro?
Sure, but when it's
Sir, which
Just a second. Yes, Arithro.
which problem?
This was in the worksheet. Arithro, I want you also to go through the worksheet that I had uploaded in the WhatsApp group.
Yes,
It has
sir.
some really good questions. Some questions are really good.
Yes,
Okay.
yes.
It's from here. Yeah. Yes, Tarun, you were saying something. Yes.
so for 101, it has it's 1 0, so it's okay. I got it. Never mind.
1 0, k will be 10. It's 10 power k plus 1, right? So k will be 1 plus 1. 2 zeros means k is 2 plus 1. 2 power 7 minus 1 zeros means k is 2 power 7 minus 1 plus 1, right? So
Yes,
this is the
I,
product. Yes. Yes, Tarun.
do we simplify 2 power 7?
No,
Right.
okay, you can. It's 128. Fine. It's 10 power 128 plus 1. Huge number. Huge number. Okay. Yeah, you can write it as 10 power 128. That's okay. But what shall we do after this? After this,
Uh,
so you have to gather the terms here. You have to gather the terms, which is uh, just for once. For once, multiply all. See, when you do this multiplication, there will be how many terms? Total, how many terms will come?
127.
127. See, if you multiply these two terms, you get 3 terms. Okay, 10 power 5. Okay, my point is, we can write one of the terms is first multiplying all 10 power 2 into 10 power 3 into 10 power 4 into so on, dot, 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 into 10 power 128. This will be one term that comes. Do you agree?
Oh, yeah.
Yes.
Yeah.
Plus next term, plus next term, 10 power 2 into 10 power 3 into 10 power 4 into so on up to 10 power 127 will come. Okay, into 1. Last term we are doing into 1.
Oh,
In the first
yes.
few, you understand the idea? Yes.
Uh,
In the,
no, sir.
see, I'm just multiplying this, but somewhat cleverly. The clever means first multiply all the highest powers, then multiply all the highest powers except the last power, except the last one. Okay.
Okay. Yeah, I
Here,
understand.
10 square. Can you just think about it like this? In the next class, I'll give you a full solution of this. So next class, we're going to immediately start a new chapter after this solution. Okay.
Yes, sir.
But the idea is you multiply terms in ascending or descending order. Like choose an order and multiply them. Right. And then you will get a nice, in the end, you will get a nice geometric progression. Like you may get a nice geometric sum.
Okay, sir.
This was also this was also a very recent RMO question. This was also an RMO question. You can think about this, and tomorrow, if you think about it a little, tomorrow in school I can explain to you the rest of it.
Thank you,
It's
sir.
fine.
Yeah, it's
So next class, new chapter. Okay, please don't miss it.
okay.
Yes. Okay, I will see you all. Have a nice night. Bye. Good night.
Thank you, sir.
Thank you, sir. Bye, sir.
Thank you
Thank
all.
you, sir.
Bye bye.
Thank you, sir.
Thank you.